Here we are. Okay. All right. Thank you for coming. This is SCaLE, the next generation. For those of you here and online, thank you. And before I introduce it off to our speakers from Roosevelt High School, I would like to thank our sponsor, OpenSUSE Open Build Service. OpenSUSE Open Build Service offers powerful team and project collaboration features for forking of packages and merge requests. OBS builds DEBs, RPMs, and TGZs for ARM, V5, V7, V8, x86, and more for 28 Linux distributions. Pull code directly from Git or SVM and build packages in a fresh VM with OpenSUSE OBS. So if you're unfamiliar with OpenSUSE Open Build Service, look them up after this talk is done. And now I'd like to hand it off to Yolanda, who is working with these fine students here from Roosevelt High School, who will introduce them and their talk.
Hello, everyone. Welcome to Hacking the Finch. I am Yolanda, and here with me I have members of the All-Star Roosevelt High School Cyber Team.
Oh. Good afternoon, ladies and gentlemen. My name is Imtiaz.
Good afternoon. My name is Gerardo Cosio.
And my name is Daniel Valadez. Good afternoon.
They will be discussing and demonstrating their experiential learning in building the Finch and in also applying Snap, an open source programming language. From an educator standpoint, I am constantly asking the question, what more can be done to ensure that the present-day education system adequately prepares the next generation to be college and career ready in a rapidly changing world? An answer to that is integrating available resources, open source educational resources, to increase interest in STEAM-related careers, and by providing a collaborative learning environment founded on peer teaching and knowledge sharing to effectively implement work-based learning practices. Throughout this project, each student brought with him a specialization, exploring solutions and alternatives as a community of thinkers and doers limited only by their imagination. Through experimentation, prototyping, and testing of new ideas, they applied important 21st century skills of critical thinking, risk-taking, and problem-solving. Having this opportunity to share with the SCaLE community further reinforces their achievements while connecting classroom learning to the real world. So without further ado, please put your hands together for Imtiaz, Gerardo, and Daniel.
Wow. Thanks, Ms. Cole. Appreciate it. So we are here to present Hacking the Finch. So, what is the Finch, and what is its purpose?
Well, Imtiaz, the Finch is an advanced robot for computer science education purposes. It is to teach students how to code a robot, or in this case, the Finch. There are many programs out there that you could use to program the Finch, such as Snap, like Ms. Cole said, Python, C++, and many more.
What is Hacking the Finch?
Well, the Finch had many limitations. One of them was their USB restriction that could only send data and power. We wanted to change that, make it wireless. We'll describe that later on in the slide. Why did we want to modify it? Well, because we want to go beyond. We want to expand the Finch, make it more interactive and entertaining. We didn't only want to do drag and drop interface like Snap. We wanted to change it and make it into coding in Java.
What can the Finch do? The idea of modifying the Finch and increasing its functionality was so thought-provoking that we felt that look, this Finch, which is the original Finch right here, it wasn't that challenging enough. It was just tethered to a USB, and it had no other functions other than just using Snap. So we decided, hey, let's take this, let's make it better. Let's add a wireless IP camera, let's add a wireless speaker, let's have it interact with the audience so we can make it more fun. Let's amp this up. So the capabilities of the old Finch include speed, steering, LED lights, wireless camera, speaker, and more. So all of which we will show you through the open source computing with Snap. So what did the old Finch do before? Well, I'll tell you. So the first component, the accelerometer, is which documents the speed at which it accelerates and when the speed changes. The next component was the obstacle detection system, where the Finch detects objects. It just reports if there's objects anywhere 3 to 12 inches near the Finch. But what was like the downfall of that was that you still can't avoid it unless you program the Finch to avoid certain obstacles. Another system was that the temperature sensors, it could detect when the temperature changes in the room. Also, the lighting sensors was when if you were to point like a light source, the Finch would follow it. But due to since during the building process of this Finch, we tested it in a well-lighted room like this one. Yeah, so in a well-lighted room, so we couldn't exactly test that part aspect. Also, the multicolor LED lights, as you may have seen in the beginning of the presentation, provides a wide array of colors in which the Finch can present its mood, if you will. And also, it used to emit sounds. But the thing about the sounds in the original Finch was that when it would talk through the computer speakers. And we felt, no, we want to change that. We want the Finch to talk. So that's why we added the wireless speaker. Last but not least, the motor wheels are specifically used for direction and speed. And the USB is used to give the Finch commands so that we can code it through Snap and that it could get powered when it's moving. So you must be wondering, what did we add or hack to the Finch? What we did was we added a visual and auditory effects. With the wireless speaker, we wanted it to communicate and interact with the audience so that we could say, hi, hello, we're communicating with you. And the speaker was so, the IP camera was so that it could view the audience and you could know that, oh, we're looking at you, and you could talk into the built-in mic within the camera, the Finch. So in addition, to make the Finch more accessible, we were fortunate enough to have a 3D printer in our school. So that's why we were able to modify the base of the Finch and the wheels. So the base of the Finch, we 3D printed through another source called Tinkercad. We used a free trial version to modify the base of the Finch for stability of the heavy equipment. And we used the 2 back wheels for more support, as Jerry will show you through Tinkercad.
Well, this was the original design we came up with. The problem was, before we printed it out, we didn't know we measured it wrong. We only measured the inner part, not the outer parts of it. So this part where the wheel was going to go, it was too tight. It wasn't going to run like that. The wheels was touching the plastic, and it would just stay there. Also, when we added the wheel, the supporting axle was going to go there. We didn't measure that the wheel was going to be big enough, so we had to cut part of it right here. We actually did cut it with my colleague, Daniel, and we measured it, everything, and we had to reprint another object similar, which is this one.
So if you're wondering what we did wrong, yes, we did measure the wheels wrong. But we did change it up though. Like as Jerry said, we cut it up because the wheels were like just stuck in one place, like it wasn't moving. So in order to give it some leg space to run, we kind of like chopped off the little sizes you can see right here, like there's space so that the wheels could like move, as we'll show you in our demonstration. So Finch creators, if you're here and you're listening and you're looking to hire, we have your next robot here, and for computer science education, and it's the next big thing. Go there. So, guys, we will now move on to our demonstration.
Sweet.
told me that.
It died.
I think it did die.
Oh crap.
What's it?
Okay. Do we have the?
Put him on the
Get the power source.
connector. Oh crap.
Connect on the power. Okay, so now we will move on to like our demonstration where we open up Snap, the open source coding page, where we will show you, like I'll narrate while my colleague Jerry, while he programs it to move, I'll dictate what happens right now. I'll narrate to you right now. Alright. Start. So right here you can see that the Finch robot's moving and it's providing a green light. Okay. Okay, now it's moving back with the red light.
Due to the circumstances that while building the Finch, it was in floor. It was in carpet, so we didn't measure the.
So what he's saying is that we tested a 3D. We tested the Finch on a different terrain, which was like marble floor. But since this is carpet, it's having a hard time turning. So next time, like in the future, like as we'll say later in the presentation, our goal is to like make it compatible with all terrain.
Hello, my name is Finch. My function is to help students learn how to program me and the different way for me to work. I want to thank you for coming to see me. I also like to thank these boys for my new body and components I love in it.
Good job, Finch.
Keep going.
Oh.
Which one are you doing?
Which one are you doing?
Oh, I'm not on to the next one.
Come on.
The presentation. The Finch is going home. Alright. Next. So our personal experiences. Jerry, talk about chops.
Well, the Finch is made up right now. It has a camera, the speaker, wheels, and base. In the future, we have problems coding it with Java. Due to the lack of time, we had to study and do the Finch at the same time. We didn't have really much time. We also want to make it smaller because it's too big, and for the power that it's giving right now, it's not going too fast. Also, we need a sturdier axle because all the weight is in the back and it's only the metal frame in the back. So we had to make it better. Also, during making it wirelessly, we couldn't do it because we had trouble doing that. While soldering all the parts together with the wireless receiver, we burned it.
It was an accident.
It was
okay.
Yeah, we soldered wrong.
Yeah. So at this time, we were able to achieve at least our goal of increasing the functionality of the Finch, but being full-time students, time was a constant factor. And since we had to prioritize our education and keep up with this presentation, the Finch, there you go, it was struggling with the terrain, and making it wireless was just, what Jerry was saying, was just so complicated because you have to use Bluetooth to make sure that it could receive the code. And then power was another challenge because you have to add a power source and you have to make that wireless too, because this is solely dependent on the USB cable. So it was just really complicated, and we just went with the USB design. So despite this, we kept our ambition and we pursued to make this Finch more appealing and more attractive than the original. Talk about the budget.
Well, also, our power budget was bigger than our expectation. So with this setback, we couldn't really modify the Finch at this time.
Talk about your speech.
Okay. Oh well, and I also want to put out my first years in high school. When I wasn't really interested in anything in there, but when I entered my A+ certification class, that just opened my eyes because of all this new technology that we have, such as the 3D printer and the Finch. Being there, I'm a senior now. Being in that class for 4 years, I have experience and I know that I'm good at what I do. So, in the future, I want to create something, just like how me and my colleagues did. We modified the Finch. But what I want to do, I want to make something better. I want to create something that will help everyone in the world in the future, for schools, homes, hospitals, everywhere.
God bless America. P.S. Stay on school.
So, we're not done yet. So we were able to apply the curriculum we learned in school to our Finch robot, and we applied these concepts from STEAM technical courses such as A+ certification and Cisco Network Academy. And because of these courses, we were able to apply to the Finch, and now we're inspired and infused with the belief that we can make something that will not only impact our school and education, but it will impact real-world application in the world around us. And so as Danny was talking about his experiences as he did his 4 years in school. So now I'm a junior, and I'm about done with 3 years of my school. And my personal experience is when I was a freshman, the first time I walked into my teacher Cole, man, I feel so old right now. He's right there in the back. It's 3 years now, and I remember the first time I walked into that class, I smelled like a fresh scent of computer chips. And that stimulated my interest. And as soon as I smelled those computer chips, it's ironic that I figured what I would want to do with the rest of my high school career and what I want to do from that point on. That I want to stay with STEM and I want to keep moving on, STEAM. So for that, we wanted to for that reason, since I already mentioned Cole, we want to thank Cole and Miss Cole because if it wasn't for them, we wouldn't be exposed to this open source technology, and they helped us in the building process of the Finch. And of course, special thanks to SCaLE, of course. Woo! Yeah. You presented us with the opportunity to present, and because of you, now we're doing this for a reason, and we're inspired to do bigger and better things. Okay, so I want to thank you for being an amazing audience. I want to thank you for being an amazing audience, and since it's our first time presenting at SCaLE, we would like feedback, and we'd want to open the floor for questions so that we can improve our presentation for next year. Because since Danny's graduating, me and Jerry, we're going to be back next year with even something better. So we would like some feedback and some questions so that we could improve our presentation. Thank you.
Thank you, Chair.
We open the floor to any questions. Well, because it gets power from the computer to operate the Finch, and also it gets code from the open source software. I hope that answers your question. Any more questions? Yes.
I have a question. I see that original design very, very cool. Why did you decide to go this way as opposed to the standard kits that are out there, the Mindstorm, the Vex stuff? Why you decided to go this particular way?
We went with this design. Well, I would have Jerry explain it since he designed it. He would have a better explanation.
Well, we designed it because we wanted to make it more entertaining. So we just didn't want to program and make it run and just see it and then just leave it right there. We actually wanted to do way better, make it wireless so we could just go around the school scaring people out. Also, well, programming the camera was hard.
Yeah. Was your question about the design, or was it because like, otherwise the answer would be like it's because of the weight. We wanted to add the wireless speaker and the camera, so we went like a flat design, like a basic flat design where it'll hold all the equipment. But if your question's about like why the design's flat, yeah, that would be the answer. All right.
Okay.
Yes.
Any more questions for me?
Do you have any big future plans involving the camera or the speaker, or any other things that you might want to add on to the Finch?
Oh, definitely. We were talking in the back. Let me go back to that slide. So we want, since we operate through the drag and drop interface Snap, our goal in the future is to code it through Java. Since being full-time students, coding with Java was kind of like a difficult time constraint for us, and we felt limited. So we are definitely looking forward to coding it with Java. And we feel that we can make the wheel sturdier because I don't know if you noticed on the terrain, the wheel is kind of like struggling to make like sharp turns. So we want to make it so that the wheels are compatible with all terrains, and that it's wireless, of course. Yeah.
And that we don't burn the circuit.
We don't. Yeah.
Why Java?
Why Java? Well, it's because that's the language I learned first. Yeah. What coding language would you do it with?
Python?
Yeah,
We'll do Python too. Any more questions? Good.
Any more?
Yeah, plus one. Is there any other questions or feedback you can give us? Yes.
The solution to your turning would probably be to put a movable wheel on the back.
Oh, it's
So
good.
that, because those two wheels are locking it from turning.
Mm-hmm.
You know, like a tail dragger airplane has a wheel on the back that can move.
Mm-hmm. So
Because
you mean like
it would allow it to turn. Those two are fighting the turning action.
So you mean like a third wheel in the middle or something, so it could help it transaction to turn?
Just the third wheel off, just the back wheels.
Mm-hmm.
Remove two back wheels and put one wheel in the center that actually moves, turn, it has the ability to turn.
Wow, yeah. Yeah. Yeah, no, I appreciate it. No, I appreciate it. If you guys have like feedback like that, I'm more than happy to hear it because what makes it better. You have any more feedback like that? Damn, that was amazing.
Yes.
I don't remember, you said that it has a microphone. Did you actually get the microphone working? Because it's not on present or future.
Oh, it's from the camera.
So you do have it, so if I say something to it, it understands. Do you like have any, I would say future, like if you don't already have it, adding something open source that like does voice to text. I'm sure there are a lot of things like that out there.
Yeah.
So then it could actually interpret it.
Oh, so you mean like when?
Cool if you don't have it.
Oh, it's because when the camera visualizes, you mean like so that you guys like would test it out by talking into it and we could hear it? Okay. Yeah, that's what you said with the wire burning. Yeah. Messed up with that. But other than that, the camera still visualizes people. So yeah, we messed up with that. Any other feedback or questions, please? Yes.
Just in terms of the presentation, as you can see, you guys coming and speaking here, a lot of people want to come and see you, and some people were going up front to see what was going on. So if you have a way to either rise the platform so people can see it turn and move, or to focus the camera on it that's on the screen so people can see, so you don't have that big crowd you have.
Yeah, that's true.
Well, we can't, right now we can't put the camera because our plan was making it wireless, and the camera.
Yeah. Oh. It's because we didn't encounter like the terrain being carpet. It's been a year since I've been here, so yeah, I was hoping it'd be marble floor.
I mean, you can record it moving in the expected terrain and then just put in a video into your presentation as well. That it's showing the ideal situation of this is how this works and see how it can move around in the ideal situation as well.
Right. So that we're not making it up. Gotcha.
It's okay.
It's on the floor and like I can even see it like on the carpet from where
Oh.
I'm sitting.
All right.
So,
Definitely. We'll definitely like look to integrate that. Yes.
What advice would you give to college students?
Hold on.
Stay in school because he's been ditching all his classes. Stay in school, read, follow, listen to your teachers. Don't ditch.
Just because, so.
Don't do
Stay
that.
in school.
That's-
All right. Any more questions for you right now?
No, that's it.
All
Okay.
right.
Kevin, thank you. That's it. Okay.